Okay, the best way is look at what's happening from one number to the next number. And usually you're either adding or subtracting a number or multiplying or dividing by a number. So from 20 to 16, we're subtracting 4. From 16 to 11, you subtract 5. 11 to 5, you subtract 6. So you do a couple and you try to see if there's a pattern emerging. If not, maybe you need to try something else. But it does look like there's a pattern emerging here, right? So let's see. If I subtract 7, yeah, that's -2. And then I subtract 8. Oh my God, that's totally the pattern. So then the next one would be what? -9. So what's the next number? -19. Okay? Again, some of you will just look at that and you're like -19. I can't. I have to do this. Okay? All right. So what about here? From 2 to 4? Times 2. Times 3. Times 4. Times 5. Times 6. And then what? So what's the next number?
980. I mean 100. Yeah,
9,080.
9,000.
It's 10,080.
10,000.
Yeah.
Wait, I gotta think about that. Oh yeah.
Yeah? Okay.
Wait, that way one essentially. I just did it on my calculator.
So we multiplied by 5, by 6. Oh. Okay. All right. A counterexample. All right. So a conjecture is based on several observations, right? And it may be true in a lot of circumstances, but it might be false in some other consequences. In order for you to say that a conjecture is false, all you need is one example. So for example, if somebody came up to me and said, oh my gosh, Miss Malikan, did you see all the 9th graders were wearing black today, right? All I have to do is point out one student, right? One student and say, oh my God, I just saw Owen. He was wearing blue. And that's it. That is false. Okay? So that was a counterexample. Okay? It's just one example. In order for a conjecture to be true, it has to be true in all cases. There cannot be a single counterexample. Okay? Now, a counterexample can be written out in detailed words, but you can also make a detailed drawing because this is geometry ultimately for your counterexample, but it's got to be detailed, specific, okay? You got to like cross all the I's, no, T's, dot all the I's, all right? So, you know what I mean. Okay. Determine whether each conjecture is true or false. Give a counterexample for any false of conjectures. Angle 1, okay, so you're told, okay, you're given angle 1, and angle 2 are supplementary angles. That's what you're given. Angle 1 and angle 2 are supplementary angles, okay? Can you make a conjecture? Can you say then, can you assume that angle 1 and angle 2 are both right angles?
False.
False, why?
Because you can also have, let's say, one that's like 179 and one's 1 degree.
Precisely. So rather than having to write that out, you could just draw an example. So look, you could draw an example like this, and you can say, so, let's say this is, 130 degrees, and this is, how much would that be for them to be supplementary? 50 degrees. Okay, is this enough? Not enough. Why is it not enough? Because look, you were told that these angles are angle 1 and angle 2. So now you want to label one of them angle 1 and one of them angle 2. Okay? So you can say that. Or you can say measure of angle 1 is 50, measure of angle 2 is 130, and that's another way. All right? So you can either use a drawing or, words or symbols, okay? If you want to write out a sentence, fine, but this is also sufficient. Okay, given points A, B, and C are collinear. Can you say that B is between A and C?
No.
No, because it could be in the other order, right? So it's false. It can be true, but there is also, it's not true in all cases, right? Because it could also be that, I don't know, it's like A, C, and then B, right? And that's it. One example is enough to prove it false. It's an all or nothing deal, okay? Given n is a negative number, conjecture n squared is a non-negative number. True or false? True. Okay? Because there are no cases. You cannot come up with a case for that to be false. Okay? Fun, huh? Yeah? I find teenagers are really good at this when they're talking with their parents, right? Because you're like, when your mom or your dad, they tell you something, you're like, not true. I just saw so-and-so, and they, So you guys are good at that. Right? Huh?
Oh yeah, that's it. It goes both ways.
Right? Yeah.
It's mutual.
Yeah. Like all my friends get like, blah, blah, blah. And your mom will be like, yeah, but I know so-and-so's parents and they don't always them.
Bad grades. Well, he got a good grade.
Even if everybody gets a bad grade, I'll also be like, well, you should have gotten a good grade. That's on you.
I mean, yeah.
Oh, yeah, it is.
Listen.
Still. That clearly means the hardest science.
So we know your parents can be really good at geometry, right? Yes? Yeah. Okay. All right. So a conditional statement is what we're doing next. A conditional statement is something that we write in what we call if-then form. For example, if you buy a car, then you get $1,500 cash back. Okay? So if blah, 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 then blah, blah, blah. There is like a whole world of this reasoning, critical thinking stuff where there are symbols for this. The symbol for if-then statements is P arrow Q. That's it. No if, no then, just P arrow Q. Okay? The P is you buy a car. The Q is you get $1,500 cash back. The way we read this is not P arrow Q. The way we read this is if P, then Q. Or P implies Q. Buying a car implies you get $1,500 cash back. Okay, just some notation. So you can take most statements and you can put them in if-then form. For example, a 5-sided polygon is a pentagon. Fine. The if-then form is if a polygon has 5 sides, then it is a pentagon. So if, then, right? Do you see what happened here? A 5-sided polygon is a pentagon. So your sentence has to as far as English grammar is concerned, make sense. So it needs a subject, right? If a polygon has 5 sides, then it is a pentagon. You can't say if a blah, right? It's a polygon. All apes love bananas. Okay? This was kind of tricky. So you're like, okay, if an animal is an ape, right? Now we're introducing some words in here. Then it loves bananas. Okay? You guys will get the hang of this. If-then statements, like we said, are called conditional statements because for something to happen, there has to be a condition that's satisfied, right? The condition that has to be satisfied is the hypothesis, right? So the hypothesis is the stuff that comes after the if. The conclusion is the stuff that comes after the then. So if, and then everything that comes after it is the hypothesis. Then everything that comes after it is the conclusion. Okay? All right. So identify the hypothesis and conclusion. Usually these are rather straightforward. So what do you think? What's the hypothesis here?
Points A, B, and C lie on line A.
Okay. Okay, so what you want to do is this. You want to first isolate the if and the then because those words are not part of the hypothesis and the conclusion. So this points A, B, and C lie on line M. That's the hypothesis. The conclusion is they are collinear. Okay? All right. So tell me, what's the hypothesis in the next one? Oh. Yeah, Leah, what were you going to say?
I was gonna say the Tigers will play.
Yeah?
The hypothesis would be like, they win their next game, they play in the tournament.
Okay. So, where is the hypothesis found? It's the stuff that follows the if.
They win their next.
So find the if, because look, somebody twisted the sentence around. Instead of saying if they win their next game, then the Tigers will play the tournament, they twisted it around. So now the if is here. The Tigers will win the tournament if they win their next game, right? They twisted it. So this is the hypothesis. So look for the if. And then the hypothesis is this one. The Tigers play in the tournament. Okay? All right. Write each statement in, okay, so let's write things in if-then form. One more thing about this one. You could also take the subject and put it here, right? So you could also, instead of they, say the Tigers here, okay? So it makes like more like syntax-wise sense, okay? All right, so here we go. Write each sentence in if-then form. Rectangles have 4 right angles. We need an if, we need a then.
If a shape has 4 right angles, then it is a square. I mean rectangle, sorry. Well, it could be a square.
So it's the other way around.
If the shape is a square. It has
Right.
4 right angles.
So the thing is, the statement is saying
I see.
rectangles have 4 sides, not 4 angles, not 4 angles, then it's a rectangle, right? So if you were right though, if a shape, you were right, I liked how you started. If a shape is a rectangle, then it has 4 right angles. By the way, when you're writing a statement in if-then form, it is not up to us to judge whether or not that's a true statement. Because sometimes it's going to be true, sometimes it's not. Our job is just to transfer it, true or false, into the form, okay? Owen.
Oh, can I do it?
Yes, so math teachers love to solve problems. Okay, that is a true statement. Yeah.
If you are a math teacher, then you love to solve problems.
Right, yeah. Or, to make it more generic, so if, that's very good. If a teacher, I would have given you full credit for that. If a teacher is a math teacher, then they love, just notice it's not like, it's love solve problems. So you have to establish the premise, right? The premise is it's a math teacher. The premise is it's a rectangle. So if a teacher is a math teacher, then blah, blah, blah. Okay. Now, what if, okay, we can exchange the hypothesis and the conclusion. So what if I can say, if a teacher loves to solve problems, then they are a math teacher. That's like the opposite. We don't call it opposite, we call it the converse. And these are not shoes, it's just the statement, right? So the converse is when you exchange, so then it becomes Q to P, okay? So this is the conditional, the if-then form. If 2 angles have the same measure, then they are congruent. Now we're going to switch it. Notice you have to do a little bit of like grammar, like you have to make some grammar decisions. So, keep the subject here. If two angles are congruent, then they have the same measure, right? It doesn't make sense to say if they are congruent, then two angles have the same measure. You want you want to introduce the subject there. Okay, so let's do these. I love these. Okay. We're going to write the converse. We're going to determine whether it's true or false. If false, we're going to do a counterexample. So, Lexi, you want to read the conditional for us there?
Yeah. If a person has a driver's license, then they're at least 16.
Okay, can somebody tell me the the converse? Go ahead, Madeline.
If a person is at least 16 years old, then they have a driver's license.
Fabulous. Fabulous.
Well, wouldn't it be if a person has a driver's license, then they're 16 years old because the if.
But we're doing the converse.
But that was the statement. Now we're switching it to make the converse.
Yeah, we're doing the converse. Okay.
Yeah. 16 years old. Then it is a little bit of writing. They have a driver's license. Okay. Now, look at this question. Is the converse true or false?
Converse is false.
Converse is false, right? Because I was 16 and just lazy getting my driver's license. So I didn't have my driver's license. Huh?
It said at least 16, so it could be 17 or 18.
Yeah, but it doesn't mean that you now absolutely have your driver's license. Because what if somebody lives in New York and they just ride the subway and they don't have a driver's license? Right?
In either way,
My uncle,
in
he's
either way,
actually
in
disabled
some
and he can't
countries,
drive, so.
even in some other
Yeah, it's a
states,
true example.
you get
Okay.
a driver's license earlier than 16 in some states.
Right. Okay. So now you have to give a counter example. If this is false, give a counter example. And you literally have to say, I don't know, like Jordan Smith is, 18 and he doesn't have a driver's license, Okay? So you can say like, all right, I'm going with Jordan Smith is 18 and he doesn't have a driver's license, okay? ... Okay, conditional. Aaron, can you read the conditional for me, please?
Adjacent angles have a common side.
Okay, now, we can't write the converse yet because it's not in if-then form. So let's put it in if-then form first. Who can help me put it in, yeah. Go ahead.
If there's adjacent angles,
Uh-huh.
then they have common side.
Good. And an easier way, maybe, is you can also say if two angles are adjacent, then they have a common side. Okay, so who wants to give me the converse? Rihanna.
If two angles have a common side, then they're adjacent angles.
Yup. Okay, I'm like rushing now. Then they are adjacent. Okay. True or false?
False.
I-
Because adjacent angles have to have a common vertex and side.
Oh, yes, and no
Common,
in
in
interior points. Yes. Okay. So it's false. Because adjacent angles, yes, they share a common side, right? But they also can't have any interior points. So for example, look at this counterexample. So this is angle A,
This be your,
B, C.
this be your counter.
This is the counterexample. A, B, C, and then look at this one, D. Now, look at the purple, okay? And look at, I'll go with the red. Look at the red and the purple. Do you see how the red and the purple, yeah, they share a common side. Yeah, they share a common vertex, but they're also sharing like interior points. Do you see that? So sharing a side doesn't mean that they're adjacent. Yeah.
For counter examples, are we allowed to do drawings?
Yes. And then you can say C angle, because this doesn't tell me much, because I don't know what you mean by this. You can say like CA angle ABC and angle ABD. Yay! Look, we did 2 sections in very little time. Okay? All right, so let's move on with our agenda.